3 decades in the past, a remarkable feat of engineering emerged, defying all expectations. A colossal undersea megatunnel costing US $15 billion seamlessly linked two of the globe's pivotal cities, with the involvement of 1,300 laborers. This subaquatic marvel extended a staggering 50 kilometers beneath the ocean's surface. The construction spanned 6 years, yet its conceptualization dated back centuries. The ambitious project teetered on the brink of failure, nearly causing strain between two nations and instilling doubts about its completion. Many questioned whether this monumental endeavor would ever reach fruition, such as the narrative of the Channel Tunnel, heralded as the seventh wonder of the contemporary world. In the present day, the Channel Tunnel stands as an essential element of infrastructure. Often overlooked by many, traveling from London to Paris has become a routine affair. A simple trip to Pancras station, a quick boarding of the train, and you find yourself in the heart of Paris within 2 hours, provided everything runs smoothly. Despite occasional strikes and recent instances of flooding, this tunnel has steadfastly connected the UK and France for numerous decades. Its significance extends beyond the confines of Paris. The Channel Tunnel links London to the expansive rail network of the entire European continent. Freight transportation has been revolutionized, making the movement of goods from the UK to Europe more convenient than the ease we experience today. Contrasts sharply with the pre-tunnel era, when crossing from London to Europe involved navigating the turbulent and notoriously unpredictable weather of the English Channel. Previously, the journey took approximately 6 or 7 hours by rail and ferry from London to Paris. Thanks to the tunnel, the duration has been reduced to a mere third of the time. Remarkably, over 20 million individuals utilize the tunnel annually, surpassing the combined population of London and Paris. The Channel Tunnel comprises two primary tunnels running parallel to each other, accompanied by a smaller service tunnel, measuring 4.8 meters in width. This service tunnel serves the dual purpose of ventilation and providing access. The main tunnels, each boasting a diameter of 7.6 meters, are strategically spaced 30 meters apart, with ample height to comfortably accommodate a double-decker bus. Every 250 meters, inconspicuous ducts connect the main tunnels, playing a crucial role in dissipating air pressure ahead of the train. This helps alleviate aerodynamic drag, contributing to the tunnel's ability to facilitate faster train movement. The overall length of the tunnel spans 50 kilometers with a substantial 38 kilometers located beneath the seafloor. Contrary to a straight trajectory, the tunnels follow a series of curves both vertically and horizontally, ensuring they remain within the chalk layer at the channel's bottom. Notably, the tunnel reaches a depth of 75 meters below sea level at its deepest upon its inauguration in 1994. The American Society of Civil Engineers bestowed the tunnel with the distinction of being one of the 7 wonders of the modern world. A glance at its scale readily reveals why no other underwater tunnel had come close to achieving the remarkable feat accomplished by this engineering marvel. The long-standing aspiration to establish a connection between the British Isles and Europe persisted regardless of the occasional inclination within the UK to resist or vote against such endeavors. Great Britain is inherently intertwined with the continent on both economic and social fronts, facilitated by the flow of trade and people. As far back as 1802, initiatives were proposed for a tunnel, albeit one envisioned for the passage of horse-drawn carriages. However, skepticism abounded among many Britons who perceived it as a potential ploy by the French to stage an invasion, leading to a lack of widespread support for the idea. In the late 1950s and early 1960s, various concepts involving bridges and tunnels were introduced as potential solutions to bridge the geographical gap. The original proposal outlined the construction of 2 tunnels, with an estimated cost of USD $3.05 billion. However, the final expenditure skyrocketed, surpassing $15 billion in today's currency, and some accounts even suggest it reached upwards of $21 billion. The commencement of construction occurred in 1988, initiating a series of intricate processes. Initially, the engineering and design teams grappled with determining the precise locations for tunnel excavation. Thorough examinations of the seabed geology were conducted, revealing a substantial layer of chalk at the bottom of the English Channel. Beneath this lay a stratum of chalk marl, offering a more amenable substrate for boring. The excavation process began with the service tunnel, providing engineers with crucial insights into ground conditions before initiating work on the main tunnels. Tunnel boring machines (TBMs) were set into motion in 1988, with 5 TBMs originating from France and an additional 6 from the UK. Following the TBM's passage, cast iron segments were meticulously bolted together, and precast concrete rings were employed to line the tunnels. The magnitude of chalk extracted during this extensive undertaking was considerable, necessitating its transportation back through the tunnel via conveyor belts.
And as always, if you enjoyed this video and you want to get more from the definitive video channel for construction, make sure you're subscribed to the Tour Tech Marvels.